Okay, so in this video, we're going to take a look at a practical application for solving algebraic equations. So we're going to do this one particular problem here. We're going to go through two different ways that you could solve this. If I figure out a timestamp thing, I'll put it somewhere so you can skip to whichever method looks most familiar to you, and that's what you can stick with. You do not have to know both methods, and you definitely don't have to use both. I'm just showing both of them because you may have been exposed to both, and you may have a preference, so just pick whichever one you'd like. So the question we have here is the surface speed s in FPM, feet per minute, of a rotating cylindrical object is given by the formula S equals pi d r divided by 12, where d is the diameter of the object in inches, r is the speed of rotation in RPM, revolutions per minute. If a 6-inch grinder must have a surface speed of 4,600 fpm, what should the speed of rotation be? Round to the nearest 100 rpm and use 3.14 to approximate pi. So one way to do this, the first thing I'm going to do actually is I'm going to write this formula down. S equals, and I'm actually going to write it in its fraction format. I wasn't able to because I used my notepad to write this out. But okay, so there's our formula. S equals pi dr, I'll divide by 12. It looks like, let's see what we have. So here are the different variables. S, pi is not a variable, but I'm going to put it there anyways. We've got d, we've got r, 12 is just a 12. They did say use 3.14 to approximate pi. Okay. S, they said, was the feet per minute, the surface speed. So if I look at this question here, it says must have a surface speed of 4,600. So S must be 4,600 in this question. They also said this was a 6-inch grinder. So now I'm not super familiar with the grinder, but I'm pretty sure it's that. So and again, I'm not super familiar with this device, but I'm assuming they're giving you the diameter information of this. So I'm pretty comfortable saying that the diameter in inches is 6. Now, the one thing I don't have is r. That's actually the question that they're asking us. They're asking what should the speed of rotation be, and according to this up here, the speed of rotation is r, so r is an unknown. So what I can do is I can take this formula, S equals pi dr over 12, and I can isolate r, and then use that resulting formula to plug in the values I do have and solve. So this is the first method that we're going to do. We are going to solve for r, and then plug values in. The other method we'll do later is plug values in first and then solve for r. They both work. You're going to get the same answer for both. Like I said, you might just have a preference as far as which one you like better. Some people find this first way more efficient. Some people find the second way more natural, whatever. So in this first one, we are going to isolate r. Make sure that when you're working on this, you have had a lot of practice with the order of operations, and ideally some practice with slightly simpler equations and solving those. I'll leave some links in the description if this is a little too complex and you take a step back, because this is kind of a big one. So I'm going to write out this color here. You probably have seen PEMDAS. I like to use GEMDAS lots of times. The P in PEMDAS stands for parentheses, but to be fair, sometimes we don't see parentheses, we might see brackets instead. They work the same way. So the G in GEMDAS just stands for groupings, which includes parentheses and brackets. You can use PEMDAS if you want. And so I'm going to use GEMDAS. And the way this works is when I'm solving an equation, I always go through the problem and I see, is there any math I can do? Is there any simplifying I can do? Anything I can combine? And so I look for it and I try to follow it. So looking at this, I don't see any groupings. I don't see any exponents. I do see multiplication. Pi, d, and r are all being multiplied, but D and R are unknowns right now. Again, we're gonna solve for R before we plug anything in. So I really can't multiply those two, and even though I know that pi is going to be 3.14, again, I really can't do much, so can't do much there. As far as division goes, I am dividing by 12. Pi and 12 are both numerical values. I could, in theory, take my pi, which I'm using 3.14 to represent. I could divide that by 12, but I'm going to get this. So this would not be mathematically incorrect. It's just that it would be mathematically stupid because there's no way I want to write that whole thing out every time I go through this. So there's really no division that is practical for me to do. So I'm going to skip that for now. And then as far as addition subtraction, there's absolutely none happening at all. So there wasn't anything needed to simplify in this problem. And lots of times in the equation, there might not be. You might go through this and there might be nothing at all you can do. So once you've done that, you can do the reverse. So we got SADMEG here. So SADMEG is the reverse order of operations. It helps you undo all the math that is currently being applied to the variable you're trying to isolate. Now remember, we are trying to isolate R. So we're going to focus all our attention on the stuff happening to R. So I'm going to set up, I like to make sure when I'm doing my equations, when I'm solving, I set up a clear left and right side. Because once you get to this part here where you have SADMEG going on and you're undoing math, you're going to be doing things on both sides of the equal sign, and it can be helpful to have this line here or some kind of visual representation so you make sure you're clear for yourself on left and right sides. So I'm looking at R, and I'm going to first, whoops, use this color here. I'm looking at R, and I'm going to see, is there any subtraction happening near R? No. Is there any addition happening near R? No. Any division happening near R? Yes. I do have division by 12 happening to the R technically. So the inverse operation of division is multiplication. Multiplication and division are like fire and water. They cancel each other completely out. And the whole goal here is to continually cancel stuff out until R is by itself. So I'm going to start by canceling out that 12. I'll use the inverse operation of multiplication. And like I said, once you get down to SADMEG here, you have to do the same thing on both sides of your equation. And what's going to happen is the side that has the variable you're trying to isolate, you are going to end up with one less number or one less term. In this case, I'm going to end up completely canceling those 12s, and I'll have one less thing when I carry it down. Let me carry it down. So I had pi dr over 12. Now I just have pi dr. The 12 is gone. Over here on the left, I have 12 times s. Again, we're kind of ignoring what these are, and we're pretending we don't know what s is. So since I don't know what s is, all I can really do is just smoosh those together. 12s, and this implies that they're being multiplied. You can keep the dot there if you'd like to. You could use parentheses if you felt like it. Just avoid using the traditional x symbol because lots of times these equations use x's, and if you have an x and multiplication symbol, it can get messy. So you can use the dot, you can squish them together, use parentheses, just try to avoid the x. So we're down to 12s equals pi dr. I am still going through SADMEG here. So division, is there any division left over happening to R? No, I don't see any. Any multiplication happening to R? Yes. The pi and the d are both being multiplied by R. So I do have some multiplication that I can undo. I can unravel it. I can cancel it out. Pi and d are being multiplied in here. So I can cancel them out by dividing. I need to divide both sides. Pi and d. Now, like I said, on the side where you have the variable, you're going to end up with at least one less term every time you do this. In this case, the pi's cancel because pi divided by pi is just 1, and d divided by d is just 1. And mathematicians are kind of lazy, and we don't usually write ones down if we don't have to. So you don't need to write 1 times 1 times r. If it makes you feel comfortable, you can write 1r if you want to. But every time that you see a letter by itself without a 1, it's implied that it's there. We're just really too lazy to write it. That, and the less you have written down that you don't need, the less likely things are to get cluttered and confused. So I'm going to avoid writing down the ones just to keep it nice and neat. So over here on the left, we have 12s divided by pi d. And typically, if you couldn't do anything with GEMDAS, then there's not a lot of simplifying you're going to be able to do with SADMAG. Not always, but lots of times if you go through everything carefully the first time, then when you're going backwards like we are here with SADMAG, there's not a lot of simplifying to do. And that's the case here. We have a 12s divided by pi d. There's really no math I can do. Remember, we tried working with 12 and pi earlier, and it wasn't very good. Granted, we did pi divided by 12, but if we do 12 divided by pi, I'm guessing it's not going to be a lot better. So that's really all we can do. So at this point, I don't need to continue with SADMAG because R is completely by itself. That's what I wanted to do. R is by itself, so now I have a new equation. I will write it, I'll write it right here. And I'm going to reverse it. I know that the R is on the right-hand side here, but lots of times in equations we like to have the isolated variable on the left. So I'm just going to switch this around and say R equals 12s over pi d. So this is pretty much the same equation that I had. It's just that I have a different variable isolated. So if I need to find s, I'll use this one. But if I need to find r, which we do, I can use this one. It should be a bit quicker. So let's use it. That was our first step, isolating r. The next step will be to plug in the different values we have and actually figure out what r is in the context of this question. So they have given us s, pi, and d, and then 12 is just a 12. So let's plug those in. 12 times s, which is 4,600, divided by pi, which we're saying is 3.14 approximately, and the diameter is, 6. So I'm going to go ahead and I'm going to put this into a calculator. I'm going to do 12 times 4,600. Okay, so 55,200 and 3.14 times 6, 18.84. Oops, 18.84. Let's continue simplifying this down as much as possible. I can do division here. I can do 55,200, and I can divide that by 18.84. Okay, not great, not great, but that's the last of the math that I have to do. So let me write down a few of the digits here. I'm not gonna write them all down. We have 2,929.9. So that is what I get when I plug in all of my values. And I'm just gonna go back and double check and make sure I plugged in the right ones. Let's see, S was 4,600, check. Pi 3.14, check. Diameter was 6, check. I can double check the history in my calculator to make sure that I typed things in right, it looks like. I have my 55. So I like to just double check because the very last step is rounding the way that you're asked to round. Before you do that, it doesn't hurt to double check a few things just to make sure you're comfortable and you're sure, yeah, that's where I'm at. So I feel pretty good with our 2,929.9. The original question said round to the nearest 100, so let's do that. then we'll get our final answer. So let's see. There's the ones, tens. Here's the hundreds place. So that's our rounding digit. The number to the right of that is not 5 or above, which means I'm not going to round up this 9. I will just round off. So I'm going to end up with, rounded to the nearest 100, 2,900. And that is my R. That's my RPM. So this was one way that you could approach this kind of problem. You can rearrange the original equation to isolate the variable that you need and then plug stuff in and you can get your answer. If you're happy with this, go ahead and stop the video now, because the only thing I'm going to do next is I'm going to do this same thing, but this time I'm going to plug the values in first and then go ahead and solve. Like I said, they're both going to be the same. If you want to see that next one, go for it. If you're comfortable with this, go ahead and stop now, and I'll see you in the next video. Okay, so either you stuck around from the first half of this video or you skipped ahead to see this second method here, where I'm going to take the equation that they give me and, oh, I accidentally erased a word. I'm going to take the equation that they give me. I'm going to plug in the values that they've given me. I'm going to simplify everything as much as possible. I'm going to use the order of operations. And then when I can't do anything else, I'm going to undo stuff and I'm going to solve for R. So let's see. They have given me an S value of 4,600. Let me put my separation in there. So I'll replace the S with 4,600. Okay. I'm sure actually, let me write that a little bit lower. 600. Keep my equal sign. They have said I can use 3.14 to approximate pi, so 3.14 for the pi. Next up is D. D they said was 6. I'm going to use parentheses to indicate multiplication. R is up next, which I do not have, so I'm going to keep it as an R. And then the whole thing is divided by 12. Now, I just want to say for the record, when you are solving equations like this, you'll typically notice that even though surface speed is 2 words, we just use one S instead of like SS. And the rotation and revolutions per minute, even though that's RPM, we just use a single R. The reason why is because, and you can skip forward if you want to, but like dr, those are 2 separate variables. D represents one number, R represents another. Typically, we just use one letter per value. If we had RPM instead of just an R, it could get confusing because does R and P and M, are they all separate? Does R stand for one thing, P stand for one thing, M stand for another thing? That's usually how it would work. So I will say you will oftentimes see usually just one letter used to represent a specific thing. So it might be tempting to use things, phrases, or abbreviations that you know, like RPM or FPM. But if you can, stick to just one letter to keep it nice and clear. So now that I'm done that tangent, let's see what I can do. I'm going to bring up my order of operations. Groupings, exponents, multiplication and division, addition and subtraction. I like to go through and see if there's any I can do. So looking at this, there's not a lot going on the left side. In fact, there's really nothing going on over there. But on the right side, I do have multiplication. So I'm going to skip. I can skip right through. There's no groupings. There's no exponents. I do have multiplication. I do have 3.14 times 6. I can do that. I mean, not in my head. I can do it with the calculator. Let's do it. 3.14 times 6. 18.84. All right, so let me rewrite this. So I did not touch this, so I'll just bring it down. I did do 3.14 times 6, and that turned out to be 18.84, but I have not touched anything else, so there's still an R there, and there's still a 12 there. Okay. Keep going with my order of operations here. As far as multiplication goes, 18.84 and R are being multiplied, but I don't know R, so I really can't actually do the multiplication. that's it for the multiplication that I can possibly do. Next up is division. I do have division here. 18.84 is being divided by 12. We can try it. Sometimes just because you can do something in math doesn't mean it's going to be beneficial. Usually it'll work out one way or the other, but sometimes there are tricks to save yourself a little bit of hassle. Like in some cases, when you do division, you get this really gross long number. If you watch the first part of this video, you'll saw we got some gross numbers. This one actually worked out pretty nice though. 18.84 divided by 12 works out to be just 1.57, so that's not bad. Oops. That's pretty helpful. If we had gotten something like 0.3492157 blah 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 and it just kept going, we probably would have skipped that. And some of you are probably asking, well, what would we have done instead? So hang on, at the end of the video, I will show you what we would have done if we had decided not to divide by 12. But for now, it worked out. 18.84 divided by 12 is 1.57. It was nice. And we have just an R left over. All right, so let's go back up and look at the order of operations. We just did division, and there's no more division that we could possibly do. Is there any addition or subtraction that I could do? Nope, not a single one. So once you've gone forward with the order of operations, when you're trying to solve for a variable, I like to go backwards with the order of operations. Okay. And when you're going backwards, you specifically focus on the variable that you're trying to solve for. We are trying to solve for r. That's the one thing we don't know, so we need to get it by itself. I don't care what 3r equals, I don't care what 5r equals, I don't care what 1.57r equals, I just want to know what 1r equals. So we're going to use SADMAG to help us get there. So with respect to r, is there any subtraction or addition happening? No. Is there any division happening with the r? No. Is there any multiplication happening to the r? Yes. 1.57 and r are being multiplied. I know that because they're just squished together like that. So I do have multiplication. The opposite of multiplication is division. Those are the fire and water. They are complete opposites. They undo each other. So if I would like to undo or get rid of or cancel out, whatever term you want to use, this 1.57, I would have to divide. And whenever you're using SADMAG, the reverse order of operations, you have to do to one side what you do to the other. So if I'm going to divide the right side by 1.57, I have to do the same thing on the left side. Now 1.57 divided by 1.57 is just 1. Actually, I want my black pen back. 1.57 divided by 1.57 is just 1, and there's still an r, which is what I wanted. I wanted 1r. Now let's see, what is 4600 divided by 1.57? I don't know. Let's find out. Ooh, okay. I'm gonna just write down a few of those because I know that the question specifically told me to round a certain way. So looks like 2929.9. Okay. So I have 1r, which is exactly what I want. You may keep the 1 there, or you may ditch it. You probably lots of times will see the 1 kind of just disappear. It's invisible. I'm gonna say it a lot. I say it a lot in my videos. I honestly, I think mathematicians are a little bit on the lazy side. We don't like to write down anything if we don't have to. That, and we do like to keep things kind of neat. So let's see. We are just about done. We just have to round. So the original question way up here says round to the nearest 100 RPM. So I need to round this to the nearest 100. So let's grab another color. All right, ones, tens, here's the hundreds with my rounding digit. The 1 to the right, if it's 5 or above, I can round up. This one is not, it's just a 2, so I'm just going to round off. And I'm going to end up with the nearest 100 to 929 is just going to be 900. So 2,900 equals R. There we go. So whether you follow the first method shown in this video or you follow this method, both cases we did get 2,900. Now I did promise that I'd backtrack. Right up here, we did 18.84 divided by 12 and we got 1.57. And I said that if we had gotten something else that was like a ridiculous decimal, we probably would have skipped that step. Let me show you what we would have done instead. So let me diverge here. Let me rewrite this pretty much exactly how it was on this line. Some people might actually jump straight to this method I'm showing you here right now, just because it can be, I hate this phrase, but it's really hit or miss with what you might get when you do division by decimals, with decimals, I should say. So some people might not have wanted to risk getting something ridiculous, and they might not have wanted to waste their time, so they might have jumped right into what I'm going to show you now. So, excuse me. I'm going to take a drink. Okay, so if we had wanted to skip doing division either because we didn't want to waste time or we did it and got some really gross number, what we would have done is we would have continued to follow the reverse order of operations. I've been using it. I've been using SADMEG. And let's see. By this point in the problem, we already determined there's no subtraction, there's no addition, there is division. Now on the left-hand side of my screen, excuse me, we did that. But on this side over here, we're not going to do that. What is it? Let me know. Let me know in the comments. Is it helpful if I divide it like this? Probably not, but I'm going to try it. Let's try it. All right. So there is division. We're not actually going to do the division. We're going to undo the division. Remember that the opposite of division is multiplication. So to undo that, I can multiply by 12. And whenever I'm undoing something, I have to do the same thing to the left and right side of the equations. Now, if you'd like to, you can go ahead and you can do 18.84 times 12. And to make it simpler, you might want to even write the 12 like this. Since the 18.84r over 12 is a fraction, and regular old 12 is not a fraction, you can always make something a fraction, most of the time, by putting it over 1. So I can do 12 over 1, just to make it a little easier to visualize, because when you're multiplying fractions, you multiply the tops together and the bottoms together. So for the top, I would do 18.84 times 12. 18.84 times 12. And I get 226.08. 08. And the r is along for the ride. And then in the denominator, I would do 12 times 1, which is just 12. So that takes care of the right-hand side. On my left-hand side here, I gotta do 12 times 4,600. 655, 2. So you could go about it this way. Ideally, when you are solving, you want to have one less number at least, or one less term. And I don't. I had number, an R, and a number, and I still have number, R, and number. That's not ideal. So what I have to do now is I gotta do, okay, well, what is 226.08 and divide that by 12? What do I get? I get 18.84. That number probably seems familiar to you. If I take 226.08 divided by 12, I get 18.84. Let's carry the R along for the ride. That hopefully looks familiar to you. That's what we have right here. It's as if the 12 didn't do anything. And actually, it really didn't. If we were dividing by 12 and then we multiplied by 12, It's like giving someone $5 and then taking that $5 right back. Essentially, you didn't do anything for them. You just canceled it right out. And that's what happened. So you can skip this middle step here altogether by just going straight into canceling the 12s, dividing by 12, multiplying by 12, total opposites, just bring down the 18.84 and the R. Saves you a little bit of time, a little bit of calculations, and like I said, the simpler you can keep it, the less likely things are to go wrong. I knew a student once who took a couple extra steps and they had a 9 in their equation, but they they had to write it so many times because they did so many extra steps, it turned into a G, and they were very confused by the time they were done. So the simpler you can keep it, usually the better off you are. So at this point, we get down to basically the same thing we were at right here, where we had a number being multiplied by r, and we divided both sides by that to get a single r. It's going to be the same thing over here. I have 18.84 being multiplied by r. The opposite of multiplication is division. I will divide that out. 18.84 divided by 18.84 is just 1, so I get my just 1 r. And then over here, if I take, come here you, if I take 55,200 and divide it by 18 oops, 0.84, there's that 2,929.9 we've seen, and if I round this to the nearest hundred, it is 2,900 is my result, my answer for R. So I have now, hopefully, gone through the two most common ways to solve these problems. Hopefully I've answered any questions before they arrive, before you have them. But if you do have any lingering questions, please feel free to leave a comment. You can also check out the resources in the description. I'll leave some more. Like I said, this one was a little more advanced, so if you're just starting to solve and work with algebra, I'm going to backtrack a little bit. There are certain rules you're going to want to know, like the order of operations and how it works in reverse. I'm going to leave some resources in the description. And like I said, please leave any questions if you have them. Other than that, I will say thank you for watching and best of luck.